Alrighty. Ooh, that was a long conversation. Delete the middle node. Alright. Implement an algorithm to delete a node in the middle, i.e., any node but the first and last node, not necessarily the exact middle, of a singly linked list, given only access to that node. So I'm going to ignore the whole thing about any node but the first and last node, not necessarily the exact middle, because we don't care. Of a singly linked list, given only access to that node. So yeah, it's basically just saying delete. It's saying delete middle node. So basically, you give me a node and I will delete it. Um, yeah, and you've modified the linked list. So that's pretty. That's trivial, but it's almost not even worth writing. But okay. So a big difference between languages like what I'm gonna guess this is like Java or C++ or C or something like that, and Lisp or at least Clojure, is they do a lot of things that are by reference, and Clojure tends not to do a whole lot of things by reference in terms of your thinking about the problem. It's usually by value. And so what they're saying here is like I'm going to give you a reference, a node, right, which is a reference, right, and you're gonna delete the node when you find the node that matches that reference. I'm not going to deal with that because I don't care about dealing with things by reference. That's silly. If worst case scenario, if you have a thing that somebody's asking by reference, just give it a GUID, and now it has a value, right? Um, so why mess with that stuff unless you're literally going after incredible performance of some sort, you know? So let's first save this as the new problem. Chapter 2, problem 3, delete middle node.clj. Okay. And so now we're okay here, and so just delete. Technically, it's not a delete middle node, but I'm just going to keep the convention of calling it the name of the thing, right? I'm going to let you delete any node. Furthermore, I'm going to give you an immutable data structure, so you don't have to. So what is the complexity of this thing? Well, theirs would be linear, right? I mean, you have to walk through the node to find the one that matches, and then you have to delete it, and you do so by just taking the previous node and or keeping a reference to the previous node that pointed to you and pointing the next node or pointing the previous node to point to the next node. And I guess that's it, really. I just dropped the node that you just deleted, and just, once it goes out of reference, once that it does to say you drop it, then potentially it can be garbage collected, or maybe somebody else has that. I don't know. Who cares? So delete the middle node. So we're going to take a list and we're going to take a value, right? And we're just going to say, I mean, just quite simply remove remove the guy who's equal to in this ls, right? So we took a list and we're going to just run through the entire list and remove whoever matches this value. That's really about it, you know. If the thing actually was a list of mutable things, then the only way that the thing can really be mutable. Oh, that's not true, but yeah, who cares? They could be a list of atoms, right? Is what I am saying. And so, if you wanted to actually pass a reference, you could pass the reference to the atom, right? So rather than this being a value, you could say it's like an atom, you know, and we could just say if the atom is identical, which is reference equality, right? Then remove it, right? But that's all just stupid, and you shouldn't be doing that in the 21st century anyway. So anyway, yeah, here we go. And so we're saying ls and v. What am I going to delete? Nothing. What am I going to delete? Let's try nothing again. What am I going to delete? I'm going to delete, yeah, evidently nothing. What am I trying to delete here? Well, I had 1, 2, 3, and I want to delete 3, so I'm going to delete 3, right? I had 1, 2, 1, I want to get 1. Well, that's not actually possible, so let's do 1, 1. I'm going to delete 2. I had 2, 1, 2, 3, 3. That's a good question. Do I delete the first? Do we want to delete the first one or all of them? I guess actually this is, yeah, we actually want to delete the first one. Well, okay, so this is a fundamentally different problem that I'm solving. Because this is not a reference, this is a value. It's just not that interesting a problem, so it's just not, I'm going to do it this way and just forget it. If you want to actually do it the other, screw it. Let's do it the right way. No, there's no point in taking shortcuts. So we're going to be weird and actually hold a sequence of values, right? And because we're talking values, we are talking things that we kind of so these are the atom is a thing that is a reference, right, that can contain a value. The value is of course immutable, but the atom itself is a mutable thing through time, right? And so if you have a list, which is an immutable data structure of atoms, then each atom is itself mutable, but the list itself is not. I don't know what to say about this, really. Actually, I'm not really sure this is worthwhile, honestly. No, I don't really care to do this. This is kind of a dumb problem, and I think we should have just actually dropped it at the beginning. But so this does point out the difference between reference and values, right? In that, well, actually, I'll talk about something else too that I think is pretty interesting and is a little more subtle. But I'm going to remove, let's say I'm going to remove 3, right? Yeah, whoops, that's not where it goes, though. Alright, so logically it should actually just basically contain the same thing except 1 fewer 3. But okay, so if we actually do want to sort of match the behavior and that it takes out the first one that actually matches this value, then you know what? I got a better way to do this. I got a more generic way to do this. Okay, so now I'm saying, give me a function. Let's actually call it a predicate. Right? It's going to take the actual value you're passing in, and is going to return as sort of indicated by this question mark, a true or false, right? And okay. And so, what does this guy want to? So. Okay. So this guy needs a predicate. How about, in this case, what we were effectively saying is, are you nil, right? So it's going to remove all the guys that are nil. All right, let's say you said you just want to remove the value 3 from the list. Well, then you can do equal to 3, boom, right? what if you wanted to remove the value 2? Or how about, how about you want to remove the even values, you know? Okay, let's do that, right? How about this complicated one where you have, this isn't a good example, but let's do something that does have a reference, like, I know, and I don't have a good way of writing that in this thing right here, but I'm trying to think, how would I really do something by reference in a way that would ever really make sense. Um, I don't think I want to really go into this, honestly, when I think about it enough. I, I, I don't like anything I did here, actually. I mean, it does, I think, work, but this is just, it's getting off tangent, you know? I think the fundamental issue here is that these people are talking about reasoning by reference, which is just weird in a functional immutable language, right? It's not that it's a problem, right? But like, what if you tell me I want to literally, just a second, let me not talk and think. Um, okay. I and whatever of so map index will put the I and the value, which we're not going to use the value. It also doesn't really matter, but the I and the value, it'll make a sequence of vectors of that type. And then what we're going to do is we're going to filter what we're going to do is thread first. Map index, then we're going to filter on are u equal to the value, you know, the v passed in here, and then we're going to take the first on it, right? So that's going to be the I, and if there is an I, what we're going to do, if I, or I guess really when I, we're going to say grab, we could have actually just said f first, I guess, which we're really not using. If we did all that, we could just say when let. Okay, and then so this we got the index position of where this guy shows up, right? Where this guy shows up in this list, right? And so then we just need to I think it's split at, I think I ls. I think we can do that with a list. Let's just go check, right? This is not the one I'm thinking of. Yeah, so this is I think what we want actually. And so then we can semi-efficiently so it's going to return a let, right? Is it actually okay? Let's see. All right, split ILS. Take and drops, right? Take list and the drop list. Is that backwards? Yeah, okay. Take list and the drop list, and then we're going to basically just take. We're going to lazy cat the but last of the take list and the drop list. I think. So I think this will just concat the two. Let's just check out lazy cat. Feels like that's not what I typed, but whatever. Okay. So I think that should delete the first element that's found that matches this value. Now, yes, there is a weird thing here in that if multiple elements match the value, it'll only remove the first one. That's the whole point. If we just want to remove all of them, we just use filter or remove, right? But if we want to remove just the first one, I think this is a fairly efficient way to do this. I mean, you play a linear cost to run across the... This you should totally use as the remainder, right? But this I think you pay a linear cost for. And so let's think about what we're doing here. 1, 2, if we remove nil, well, that's not true, right? Oh, I think we're saying the other way around, right? All right. This removing nothing, this removing nothing, this removing nothing. Why are we going down in that order? Doesn't make sense. Okay. Oops. This removing the 3. And that should give us 1, 2. This we're removing the 2, and that should give us 1, 1. Okay. But we should be able to handle the case that we remove the first one, but not the second one. This is a bit out of scope of the actual crop problem, but yeah, it should. I mean, if you want to make this much simpler, just ensure that everything in here has a unique value, right? Which is not hard. That is a simple thing to do. You can, rather than passing in, you know, I could have made, I just saw a way to make this generic. We can use this map index thing we had right here, right? Where you can tell me what you want to remove. I can use the map index to find out its index position. Then I can, no matter what values you actually pass me, right? If I can do whatever equality check you want to do on it, I can find the index position of it, and then I can just use this to just delete it, you know? So, I think that should, let's see what happens. I don't like this problem, actually. Could I resolve symbol lazy cat? You know, I've had this before with Babashka, it feels like. It's like this doesn't exist? That's weird. I don't know what's up with that, so let's just ignore that and go to, how about concat? Okay. I would have to look up every single time the difference between those two things is, but... Okay, so at least we failed with a... Equal 1, 2, 1. That's weird. Delete middle node. Oh, okay. Delete middle node 2. we said it should be 1, 2, 1, but instead it was don't know how to create iSeek from Java lang long. I think I can guess what that is, but I guess maybe it should be this. That doesn't feel right, does it? Split at. No, it should be in collection, so that was the right. In collection. FF first is actually his feeling here. So I feel like I ran across, I had a vector, and then I said, oh, I see. Let's do an actual function. We ignore the, we want the I. No, we ignore the I in this case, we want the V. And we're saying, does V equal to this? Sense. Yeah, I meant, Jeez. Don't know how to create iSeek for Java lang long. LazySeek RT first, okay. It's got some problem with FF first, so let's see what we see there. A lot of errors, okay. So these should not be failing. Oh, except that we're backwards. Okay. Why is there only 3 tests? Okay, we got I of 1 and 2. Okay, so you have definitely a collection. So all I'm saying is rather than return 1, return that, return this. Okay, why was that an issue before? I don't really get it. So not equal, this is equal, oh, it's because we're returning. Okay, well, let's if-let the whole thing instead. And let's say, if we have that, cool, we can do this whole thing. If we don't have, if it doesn't show up at all in here, we should just return ls, unchanged. Okay. Now, this doesn't work. 1, 2, 3, so I think we're off by 1, it looks like. One, 2, 3 is returning 1, 3. I thought it was about last on this one. So this is take I. We're trying to get rid of the position, the item at position I, right? But the item at position I started at index 0. If you take 0, you get the empty list. Yeah, so I think we actually want to take maybe the decrement of I. Wait, what did we end up with? 1, 2, 3 became 1, 3. why I don't like doing index stuff. It's just alright. I'm literally just trying out things until I see something that seems to work. Rest of DS. There we go. Alright, whatever. I'm bored with this problem. This is not an interesting problem. Alright, okay. Commit. Just copy this form. I don't know why I did that. Alt W. Commit. Paste. Delete. It's not even well named now at this point. Oh crap, did I copy that incorrectly last time? I made a little typo, didn't I? Oh well, if I do that, unfortunately if I amend it, it's going to change the commit time, and that's just going to screw everything up, so I'll just live with it. Double check your work. Oh. W. Okay. Commit. Paste. Delete middle node. Problem 2.3. Alrighty. That's fine. Hey, I gotta take a call. So,